So hey everyone, so this is the problem 1 on the curvilinear motion. The question says that determine the banking angle. So this is the one of the places that you trust in engineer at traveling at 70 mph, more than 70 mph. So for the racetrack, the wheels of the racing cars will not have to depend on friction. So you have to put this curved angle in a way that the cars do not slide. So the mass is m, the radius of curvature is rho, and the speed is v, but constant speed. Okay, so the question says that find the angle theta. Okay, let's firstly write the force balance. If you just check this way, the force balance, we have the normal force, we have the, let me use the other color, maybe this one. Yes, this one is good. So we have a normal force, we have a weight, and then we have the, if you think this way, they are traveling in a curved loop, something like this one. Yes, this is the same car. And this car will have the AN, and then it will have AT, and then also binormal axis. But let me tell you something, yes, the AT is 0 here because the velocity is constant, since we have a constant speed. Okay, and then we have W, we have N, and then we have also the, let me show you this way. How can I do that? Okay, so we have the V, and this is the binormal axis. Yes, you have to be careful here. Binormal axis. And then we have the normal axis. This one is, let me, N, which is the normal axis. Normal direction we can call it instead of axis. Binormal axis instead of axis, let's call it direction so that this looks more appropriate. Binormal direction. Okay, as you can see, the formula car has some weight, has some normal direction, and then binormal, and it also has some tangential way, but I cannot show tangential here. But then it has also friction. Let me add that one as well. We forgot the main part. Friction is our friend, so it will have some friction. Okay, so the problem is, it says that prevent the cars from sliding, so ignore friction. Okay, so this statement says that no friction. Okay, sliding friction, actually, let me just add it, no sliding friction. Okay, so with this in mind, let's solve our problem. So we have this one with some angle theta. We have our car here with some dot. This car has some weight. It has some normal. It has some. Okay, so that's all. And then this weight has some the normal has some components. Let's write the components of the normal. So it has a normal this way, and then normal that way. So it will be that normal in normal direction, and then normal in binormal direction. Okay, so if we write the forces in n, that will be equal to mass into acceleration in n, and then we have to find the relation between this theta and that theta. That is the main part of it. So to find it, let me tell you an easier way. So then we have a theta, then move this one here, so it will be that you will have a normal, and then we will have this one, and then we will have that one. So to find theta relation, okay, so the angle between this one and then that one is 90 degrees. Okay, so this one is theta, this one is 90 minus theta, and this one and that one is also 90 degrees. So this one is 90 and that one is theta. Okay, so we do one more time. This one and that one makes 90 degrees, and therefore this part will be 90 minus theta, and that one and this one makes 90 degrees, and therefore this one will be theta. Okay, so then you will have the n which is positive, and then we will have that one equal to man. Okay. And then let me check if it is recording or not. Okay, then n is, if you look at here, then it will be that n sine theta, and then nb will be n cosine theta. So n sine theta will be mv squared by rho. That is the first equation. The second equation is that the forces adding in b direction will be 0. Okay, so that will be MAB. Okay, then B we have the W negative, and then we have plus n cosine theta, that will be 0. So from here it follows that the n cosine theta will be equal to the mg. Okay, that's the second equation. So let's combine the equations. So we have the n sine theta, that will be equal to mv squared by rho. N cosine theta will be equal to m into g. Okay, then divide. So it will follow that the tan theta will be equal to v squared by rho into g. Okay, and then theta will be arc tan of v squared by rho g. Okay, that is the relationship that we are looking for. Okay, and then as you can notice, independent of mass of car. Okay, say that the speed of car is 70 mph, and then if you know the radius of the curvature and then gravitational acceleration, then you can find the theta that is required for the cars to move, to turn smoothly. So theta required for cars to turn smoothly. Okay. That's the end of this problem, and then let's move on to the next one.